In this class, you will see design of flexible payments. So flexible payment design, we have to determine thickness of the payment, total thickness of the payment, that is surface, base, subbase, total thickness, and the surface layer, that is bituminous layer, mixed design. So what is the proportionate of bitumen and the other things? So now we will see how to determine thickness of the total thickness of the pavement. So in IRC 37 it is given, different charts are given for different CBR values. From 200 mm, starting from 200 mm, and depending on the traffic in million standard axles. We have CBR 2%, 3%, 5% like that. We have different values. And the other chart is for 10 to 150 million standard axles, IRC 37 2001. And nowadays we are not using these charts anymore. We are using different software for calculating the thickness. Anyhow, we will see how to determine CBR value and how to determine the design traffic, how to design the traffic, this traffic and CBR value. Now we will see how to determine those things. First, design traffic is given by a formula that you have to remember, that is 365 into 1 plus r whole power n minus 1 divided by r into a d say f. So design traffic, where A is the commercial vehicles per day. So we only consider commercial vehicles for the purpose of designing pavements. So commercial vehicles per day, whenever the traffic is open to that road, that is at the end of the construction of, at the end of the construction of the pavement. And this A is calculated using one more formula, that is P into 1 plus R whole power x, where x is the time difference, that is number of years between the survey happened, that is we have done a survey regarding the traffic at some period of time, and the construction will take some time, maybe a few years, and the number of years between the data, survey data and end of construction of the pavement. So that is this x, and r is the traffic growth rate. If it is given as 5%, then you have to take it as 0.05, something like that. And this n is the life period of the pavement. So generally for expressways it is 20 years, and for other types of roads it may be adopted as 15 years. And now we got A, R, N and X. Now what is D and F? So D is called vehicle damage factor. Vehicle damage factor means we have standard loads, right? Generally we have standard load. It is a single axle with dual wheels on either side. This is the standard. So all the trucks will not be like this, right? There will be tandem and tridem. This is single axle. We have similarly tandem. So two single axles with dual wheel on both sides. This is tandem. And similarly we have tridem, and it might be a single wheel on both sides, right? These are the possibilities in general. Tridem means three of these. So single axle with the dual wheels, we take it as 80 kilonewton, right? This is 80. And for tridem it is 148 kilonewton, and for tandem it is 224 kilonewton, and for this one it is 65 kilonewton. So to determine vehicle damage factor, what we do is that D is equal to load given, whatever the axle load they have given, divided by standard load whole power 4. So standard load we adopt 80 or whatever given. After conducting the traffic data, commercial vehicle traffic data, then you have to find out, depending on different types of loads on the wheels, you find out this D. Once we calculate by doing an example, then you will be understanding it in a better way. And now, what is F? F is lane distribution factor. You can call it L or whatever. So lane distribution factor, what is that? So we will see what is lane distribution factor. So we have two types of carriageways. So single carriageway, which is undivided in between, right? We have dual carriageway. So means there is some barrier in between. There is some barrier. So single carriageway, and this is double carriageway. Single carriageway, and if the traffic is allowed in both the directions, then that F should be 100%, right? So traffic data is for the both sides, and thus F should be 100%, that is 1. That factor is 1. And now, if single carriageway for an intermediate carriageway, that is width is 5.5 meter, then this factor should be 75%, that is 0.75. So intermediate carriageway, we have 75%, and if it is a two-lane road, two lanes, right? Then 60%, that is 0.6. This is for single carriageway. For double carriageway, what will happen? See, two-lane double carriageway. Two-lane double carriageway, you adopt this as, if it is two-lane, take it as 0.75. If it is three-lane, 0.6 and 4 lane and 4.5, that is 45%. So this 70% is taken because there is no rule that the vehicles traveling here should not cross here. So they'll share, the traffic traveling here will share the whole carriageway. So in that way we take it as 75%. The fluctuations will be there, movements. Similarly for, if this is for 2 lane, similarly for 3 lane and 4 lane you adopt this F. So after calculating this you will get some value, maybe something like you got it something like this. Now you have to convert this in millions. So this is 6 millions. So divide by 3.6, get this as 6 million standard axles. So we have standard axles because vehicle damage factor we have adapted and we have converted it in all into standard axles. So million standard axles, you report in million standard axles. Now how to find out CBR value? CBR value, how to find out? CBR value, California bearing ratio value. This laboratory test is similar to Proctor test. You prepare a mold according to Proctor test, modified Proctor test, and that mold you soak it for 4 days. Wherever the rainfall is more than 1000 mm, you soak it for 4 days, and that soaked sample you keep in penetration test, CBR penetration test, and the load be applied in 1.25 mm per minute. Load is applied, then you will get a curve, load versus penetration. In mm. Sometimes the curve is not like this, it may be like this also. So some convexity. Then you need a correction by drawing a tangent right, and now you need loads corresponding to 2.5 mm penetration and 5 mm penetration. So we need loads corresponding to, so this is no correction curve, and if correction is needed, this curve. So these loads, now you calculate California bearing ratio values at 2.5 mm penetration, that is equal to load corresponding to 2.5 mm divided by standard load. Standard load is 1370 kg for 2.5 mm. Similarly, CBR at 5 mm penetration is also load corresponding to 5 mm penetration divided by standard load, that is 2055 kg into 100. You need it percentage, right? Into 100. So you got two values. So CBR is generally should be higher. CBR at 2.5 mm should be higher than CBR at 5 mm. Mind you, this is not for a single sample, this is average of, you have to take average of 3 samples. 3 samples average, and 2.5 mm penetration, CBR value should be more. If it is not the case, if this is not the case, then you have to repeat the experiment repeat and find CBR again. If this is not the case, repeat the experiment and find CBR. Whatever higher value you get, whether it is 2.5 mm or 5 mm, higher value you adopt. So adopt higher value. If 2.5 mm is higher, then okay. If 5 mm is higher, then also okay. Adopt higher value after repetition. And this CBR value, CBR in percentage, the variation should not be too much. Variations of different samples should not be too much. So within the limits, there should be within the limits. So the CBR value, depending on the CBR value, variation should be within 1 or 1%, 2, 3 and 5, depending on this. And if the variations are higher, then the samples should be 6, not 3. If the variations are too much, then take 6 samples and make average of that. And now we know the CBR value and we know the design traffic. So now, depending on the charts given in IRC 37, we can directly calculate total thickness of the pavement, right? And nowadays we are not depending on the charts given in IRC, we are using different software to determine the thickness.